we will see the how the stepper motor can be interfaced with the 8085. Now here, if you see the diagram, this is the stepper motor interface, stepper motor kit. So this kit is connected to the 8085. Now here you can see these two are the 8255, 8255. Lower 8255 I have used. So now here you can see this card is connected to the lower socket. Now here, and power supply is um, applied to the stepper motor. Now this is the stepper motor. After running the program, this motor will rotate in a clockwise direction and in an anti-clockwise direction. How we are writing the program. Two different types of programs are there. Now, before going to discuss about the program, now here you can see for upper 8255 addresses are this one, and the lower 8255 addresses are these. Now I have used the lower 8255. Now I used these addresses. And this stepper motor is connected to the port A, and the microprocessor is sending the data to the port A. That's why what port A is used as an output port. And port B and port C we are not using. So you can take it as a, now what is a control word? Because this we are using in a simple IO. So first one is a 00, and we are operating in a mod 0, and port A we are operating in a output port, and this port C we are not using, so I'm taking it as output port, and port B also I'm not using, but still I'm operating in a mode 0, and port B is also output port, and port C is also output port. Now here anyway port B and port C we are not using, only port A we need to bother about the port A. Now this one, and we are using in a simple mod 0. So now if I write the command word, now what is 80H in a hexadecimal form? It is a 80H. This is a command word. Now if you take the stepper motor is having the 4 poles, and these are called the stators, and here inside the rotor is there. Now for the stators, now winding is there. Now by applying the some voltage, so these winding will, this pole will get excite and it will try to rotate. Now how to rotate, that we need to, now here only 4 poles are there. Now we need to apply the 4-bit data. Now we have to ensure that whenever you are giving the data, now in your 4-bit data, only one should be there. So now like this also you can give the data, and like this also you can give the data, like this or like this. Any one of the data you can give. Now here I am taking the 8. Now but in a microprocessor, to send the data, you can't give only the 4-bit. So you have to give the 8-bit data. Now for that what? The same data I'm duplicating it. Now this is my data. Now this is my data which I'm applying to these poles. To excite these poles, I'm giving this data. Now if I wanted to rotate this motor in a clockwise, I have to move these bits in a rotate right. Means what? Now rotate right means what? These bits should move in this direction. Means what? This last bit will come here, and one will go here, and zeros will come here, one will come. Now after this is one rotation, and after second rotation means what? So this is the second rotation, and third rotation means what? This is the third rotation, and fourth rotation means what? Again this one will come here. So now after completing the 4 rotations, so this cycle is completed, one complete rotation is done. So now after that one more rotation if we are doing, then this first one will come. So this is what? Moving the data into the right side is nothing but what? Clockwise. The motor will rotate in this direction, clockwise direction. Now if you move this data in a rotate left means what? This left side, if you try to move like this, then motor will rotate in an anti-clockwise direction. Now which program you wanted to write? So rotate right means what? RRC. Now this instruction you need to give. This is for what? Clockwise direction. Now to rotate left means what? RLC. Rotate left instruction you have to give. With this what? Motor will rotate in a anti-clockwise direction. Now for that how to write the program we will see. Now what is the command word? Already we have seen that it is 80H. So that command word I moved into the accumulator, and later I have to move into the control register. Now, what is the control register address here? 0B control register. Now I have set the 8255. So how to operate everything I have said by using this control word. Now here 88. Now which data I have to apply to the stepper motor? That data I moved into the accumulator, and that again I have transferred to the port A. Now why? Because this stepper motor is connected to the port A, and we need to give the data to the stepper motor. That's why I used the out instruction, out 08. Now after that, what? After giving the data, after this, some delay should be there, and after that, what? Need to rotate into the right side by using the RRC, and again we need to give the delay, and after that again we need to, means what? After the now here, if we are giving one like this, means what? It will take the 90 degrees, and after that, what? Again it will take the 90 degrees. So like that, after 90 degrees we need to maintain some delay, and after again some 90 degree, after the one more rotation, it has to maintain some delay. For that, what? We are writing a delay program by using the subroutine. So after setting the 88, now we are calling the delay program by using the subroutine. Call delay means what? Subroutine. Now what program we have written here? Now I have taken the register C. In that, maximum count value I have kept. So for 8-bit maximum value is what? FF only. So I am decrementing the count value, means what? From FF to I am decrementing, means what? Now FFE. After that, what? FD. Now FE, FD. Like that, it becomes what? 00 till it will not get 0. So the loop will continue, means what? Decrement will takes place. Once it will, the count C register is becomes 0, then it will come to the return instruction. Return means what? Again it will go to the next. Now here it will go to this instruction. Now again RRC means what? Rotate right. So first initially we have set this value. After rotate right instruction, what? Next the port A data will be this. So now that data we are sending to the, now here the data we are sending to the, now here if you see where we are jumping to here. Now that after rotating the data, we are jumping to here port out 08 means what? After rotating the data, that data we are sending it to the port A, means nothing but what? We are giving to the stepper motor. Again we are calling the delay. So after every rotation, what we are doing? We are calling the delay. So means what? Giving this data to the stepper motor, and after the 90 degrees rotation, we are keeping some delay, and after that we are giving this data by using the RRC, and again we are maintaining some delay, and by using this delay program. So this is about the stepper motor program by it is rotating in a clockwise direction. Now, if you wanted to rotate in an anti-clockwise direction, then what you need to do? Simply by replacing this instruction with the RLC. So this is about the stepper motor. Now, similarly, we will see the program for the DAC. Again, DAC also, now here this is the connection. This is the DAC interface kit. This kit is connected to the, again, lower 8255 I have used, and supply given. And after writing the program, if you check the output through the CRO ground pin is connected, and a positive signal is positive pin is also connected. Then square wave you can see here. So by giving some digital data, that data is converted into square wave. Now here the program is for the square wave. So for that, what is the control word? Again 80 only. Why? Because we are using, we are operating this 8255 in a IO mode, and mod 0 in IO mode, again mod 0, and we are using only port 8. That's why what? 80. And that control word is sent to the control register. Now initially, now square waveform means this is a square waveform. Initially, this value is nothing but what? 00H. First I have taken the 00 value. Now here 00 value, and I'm keeping this value for some time. So this time, so we need to put some delay over here. For that, what? Here I have written the delay program. Now here I have written the delay program. So 0, 0 I have taken, and that I transferred to I wrote into the port A. Why? Because this DAC is connected to the port A. So I have sent this 0, 0 to the port A. Thereby what it is, port A is maintaining 0, 0. And this 0, 0 should maintain for some delay, for some time period. For that what? I have taken the B register. In that D7, any random value you can take. How much delay you wanted to provide, accordingly you have to take one value, one hexadecimal value. Now here I have taken the D7. If you wanted to put some other value, you can. So depending upon how much delay you want, you can put the value over here. And here I am decrementing this register until the register value goes to 0. Now I am continuing this loop. Once this goes to 0 means what? I have to, now if this goes to 0 means what? It's supposed to jump to the maximum value. Now plus 5 volts means what? I have to take FF value. So after completing this delay, now again I'm moving this FF value into the accumulator. FF is nothing but what? Plus 5 volts. Now if you wanted to change the magnitude, now here if you wanted to take 2.5 volts, now half of FF, what is the half of the FF value? FF is nothing but what? 1111111. So if what is the half of the value? Only put the MSB value 1, remaining all you have to take 0, then that is nothing but what? Half of this value. So if you take this value, then you will get the half of the maximum amplitude. So 2.5 volts you will get. Now here I have taken the maximum amplitude, and that I'm moving into the port A. Why? Because after keeping 0, again it's supposed to jump to the 5 volts. Once it is jumped to the 5 volts means what? Once it is kept FF, this also should maintain the same delay, how much the delay is maintained over here. That's why the same count value we need to provide, and delay program I have written here. Move immediate, some same value. Whatever the value I have taken, the same value I have taken and decremented till it gets 0. I have to rotate this, I have to be in this loop. And once this is 0, then I jump to the again for this. Now after keeping some value, again I have to come back to where? Again I have to come back to the 0, 0. Means what? Here, this value. So this is jump to this value. Now for the interface and for the tag, here I am not ending the program. This will continue till we don't give the external interrupt. If you don't reset the 8085 kit, so continuously it will give the waveform. Now this is for the rectangle, this is for the square wave generator. If I wanted to generate the rectangle, means what? Off period should not be equal to the on period. So off period should be high and on period should be low. Otherwise, on period should be high and off period should be low. For that what? Here the delay value should be different. Okay. Now here if you take higher value, then you will get a long off period. Here if you take a higher value, then you will get a long on period. Like that, but instead of taking the same delay, if you change the here one delay and here one delay value, if you take, then you will get the rectangular waveform. Now to generate the triangle, then what to do? Initially you have to set 0, 0. Instead of putting the delay, now slowly you have to increment the value till you will get the maximum. And after that what? Again decrement the value till you get the 0. Now here you need to compare your final value. Here you need to compare your initial value. So like this, by writing a program like this, you can generate the triangle. Now how to generate this sawtooth? Means what? Initially you have to take 0, 0. After that, immediately without any delay, you have to jump to the FF. And after that, what? You have to FF value, you have to decrement slowly. And whenever you are decrementing, the decrement value you have to compare with your initial 0, 0 value. So like that, you can write the program for the sawtooth waveform. Now this is the DAC. Now similarly, you can write the program for the ADC and traffic light and so on.